Okay, good morning. So there is another part of this lesson left, but this is rational equations. So we want to introduce this topic. So in principle, a rational equation means an equation that is involved with rational expressions, and there is an unknown that you want to find them. Yes, there's to find it. Yes. So, and I think there is nothing very new in this lesson. We have a little bit of this. We had a little bit of this, I don't know, before, but here we want to solve a little bit harder problems now. I think it would be better for me if I start with just examples to tell you what do I mean. Okay, so I would write this example. And then if we get more time, we will practice a little bit more about this rational expression simplification of it. Okay, so solve the following equations. Yes. So number one. X minus 3 divided by x minus 1 plus x minus 1 divided by x minus 3 is equal to 25 over 12. Yes, so this is what we want to solve. Okay, this is an equation. Yeah. Okay, so here you see that I have an equation. I am using the word solve. I am not asking you simplify something. There is an equality here. I want to find that value, or probably it's better to say all possible values for x, so that when I replace x with those values, the left-hand side becomes indeed equal to the right-hand side. That's the meaning of solving an equation every time, yes? Okay, of course, I want you to follow this method, which is more efficient, I would say. So the first thing that you do, you need to look at the denominators. So here there are 3 denominators involved, yes? Why this is under this title? Because now you see that I have an equation, but this time rational expressions are involved, yes? So that's why we call it rational equations. Okay, so I want to solve that. The first thing that you need to do, this is not probably the only way, but I would say this is most efficient way to do that. So you find the least common denominator, not only for this one and that one, for all of them. So if I ask you how many denominators are involved, there are 3 denominators involved, and I want you to find the least common multiple of all these 3, yes?
Isn't it lowest common denominator?
No, it's called the least common denominator.
Are you sure?
Yes. So x minus 3 and 12.
We saw lowest.
Okay, so what is that? In this case, of course, if I ask you what is the least common multiple, what is that? In this case, for these 3 expressions. What is that?
None.
No, you are thinking again about divisors. Multiple means the expression which is divisible by them, yes?
Isn't it all of them?
Yeah, that's a product. Here, I told you that most of the time, so you need to be careful that this is not always the case that this is the product, but here this is actually the product. You don't need to write it down, I just want you to understand that. Okay, so what you do, you multiply the left-hand side of this equation by that expression. To keep the equality the same, I have to do the same thing on the right-hand side, okay? So what I do, I would write this, and then I put a pair of big brackets and put this expression inside, so it becomes x minus 3, x minus 1, then plus x minus 1 divided by x minus 3, yes? On the right-hand side, I will multiply the right-hand side by the same expression, So this becomes 12 x minus 1, x minus 3, and then you multiply it by 25 over 12. Of course, you have to be a little bit careful. I will tell you later why. What is the logic behind that? The logic behind that is that if two expressions, a and b, are supposed to be equal, then it means that if I multiply the left-hand side by, say, 5, and multiply the same thing here, of course, if they are supposed to be equal, then these two should also be equal. So that's the logic behind that. So I'm asking you to make this equality right. You are telling that, okay, instead of making this equality right, let me make this one a right equality, yes, a correct equality. So it means that I am multiplying both sides by this expression. But there are some problems that you need to be careful. I will talk about them later. Let us first improve our skills, how to solve. Okay, so what you want to do, you are supposed to multiply this, but there are two expressions here. So you have to take the whole expression, multiply it here, and take the whole expression, multiply it there. Yes? But the point is that I want you to do most of these calculations in your head, okay? So when you multiply this here, in principle, you can take this one and multiply it in the numerator, make it even bigger. But that is not the whole point. The whole point is that when you multiply it here, before doing the multiplication, remember that this factor can be simplified with that factor. Yes? This is the crucial point. And what is left? 12 x minus 3 are the leftovers, and then I take only those and multiply it here. So in your head, you simplify this factor with that factor, and then you multiply only these two into the numerator. And x minus 3 is coincidentally, x minus 3 is again, so when I multiply them, it becomes 12 x minus 3 squared. Yes? And then I repeat the process. I will take this one and multiply it here. But before multiplication, I have an addition here. And then I will do the same thing. But this time, when I want to multiply this here, this x minus 3 and this x minus 3 will be cancelled. And what is left for me is 12x minus 1 that I am supposed to multiply it into the numerator. So then it becomes 12x minus 1 squared. Yes? So is that understandable? I don't want you to write so many things to be able to write that, yes? Just write this, and when you multiply, do that part in your head and multiply it here. And what happens here, so here 12 and 12 are simplified. And then x minus 1, x minus 3 are leftovers, and I have to multiply them in 25, but usually people write 25 first and then write the expressions here, yes? So what is the benefit here? The benefit is here, I was facing an equation with denominators, so I have to work with fractions, which is harder. But now I have an equation without fractions. Hopefully that this new equation is simpler to work with rather than this equation. That's the whole point. But there is a price that we are paying. We will come back to that point again. So here, if I ask you what I'm going to do, I am going to solve this equation instead of the original equation. They are not the same equations. Yes? But what is in the back of my head is this. I want to see that I'll have to be convinced that the solution to this equation, even though different from this equation, would be the same as the solutions of this equation. Yes, that is the whole point. And sometimes this doesn't work, but be careful about that. I will come back to this later. Okay, but this is a very simple equation now. Hopefully you know what to do. You have to simplify and then try to move things around and then solve the equation. Yes? So let us do that. So here, be careful. Which one has the priority? You are not allowed to multiply 12 in because you have a power of 2. So you have to wait for 12. Multiplying 12, you just raise it to power 2 using the squaring pattern. So this becomes the first one squared 2 times the first one times the second one, and the second one squared. And the same thing happens here. So what I do, I would write x squared minus 2x and then plus 1. Yes? And on the right hand side, it doesn't matter which one you want to do first. I will keep 25. I will multiply these two. So this becomes x squared minus 3x minus x plus 3. Okay, so still I am in the process of simplification, yes? So what I have to do, I have to multiply these. So 12 times x squared is 12x squared.
But can't you factor out 12?
Factor out what?
12.
Yeah, there is no point for that. No. Because if you factor out, yes, you can factor out, of course, here. But then you have to multiply back again. So why we should do that? Yeah. No, it doesn't matter. So I multiply, so it becomes 12x squared minus 12 times 6 is 72, x, and then 12 times 9 is what? 108. And then we go to the next one, 12x squared, and then minus 24x, and then 12. Okay, here on the right hand side, I prefer to simplify and then continue, even though it is not compulsory. So this becomes x squared minus 4x plus 3, yes? And then I will multiply 25 in. So this becomes 25x squared. And then I will have 100x. And then I will have 75, yes? So still, I can't simplify even more, so I have to simplify. So 12x squared here and 12x squared there, it becomes 24x squared. Minus 72x minus 24x, it becomes minus 96x. And then I have 108 plus 12 is 120. On the right hand side, I cannot simplify more. Yes? Then what happens? It is clearly a quadratic equation, so it means that I have to move everything to the left and use a PQ or ABC formula to solve it.
Is that the price you have to pay you were talking about?
No, not the price. Yeah, this is something very good, but sometimes you see that you might have a false root. That's the problem. Yes, I will talk about that later. So what I have to do, we can, by the way, we can do it in our head. Yes, 25x squared, we move it to the left, it becomes negative 25x squared, but I have positive 24, so it becomes negative 1x squared. I move minus 100x to the left, it becomes positive 100 minus 96 is positive 4x. And then I move 75 to the left, what would be the answer? 45, yes? So be careful. Here, I haven't started solving any equations yet. What I have done, I gave you this, you multiply this by some factors, and then you got this equation. And so far, what I am doing, I am simplifying that equation. And I got that, yes? And at the end, now the solution process will start exactly from here using the quadratic formula. So let me use ABC formula. So A in this problem is minus 1, B is 4, and C is 45, yes? So if I calculate delta, delta is B squared, 16, minus 4 times that is positive 180, and it becomes 196, which is positive. Okay, and then what you have x equals to minus b plus or minus the square root of delta. Yes, and then divided by 2 times a, which is minus 2. And then if you put this in number calculator, it is 14, so it becomes minus 4 plus or minus 14, and then divided by minus 2, and then you will get 2 answers. X is equal to minus 4 plus 14 is 10 divided by minus 2 is minus 5. Or the other one is minus 4 minus 14 is minus 18 divided by minus 2 is 9. Yes? But before accepting them as the solution to the original equation, so let me ask you one question. Am I sure that these two numbers are solutions to this equation or not? To this equation.
Yes.
This is guaranteed. Because so when you want to solve this, you don't need to know anything about coming before. You just start solving them and you get two answers. So these two answers are definitely the solutions for this. And then this equation, even though it is much simpler than this equation, but they are equivalent equations. Equivalent equations are those equations that even though they look different, but the solutions are exactly the same. Okay, this is the crucial point I want you to understand. Why this equation is equivalent to this equation. What is guaranteed? So you see, I am solving this equation and I am telling you that those solutions are solutions to this equation. Yes, you have to be careful about this. Is that right or wrong? The reason is that if you see the process that took me from this equation to that equation, all steps are reversible. That is very important. Yes. For example, I went from this step to this step. Okay. Can I, in principle, go back? Yes. Here I expanded. Yes. If I want to go back, I can collect them back. So this step from here to here is reversible. Yes. And then from here to here, is it reversible? Here I multiplied everything. Here I can factor everything out. So that's also reversible. And this step is also reversible. This step is also reversible. So this is guaranteed that these two numbers are exactly the solutions for this one as well. Because mathematically there is no difference between this expression and this expression. Because every operation that took me from this to that is reversible. So I can go back. So this equation and that equation, even though they are not identical, but they are equivalent. It means that the solutions for this and that are the same. But this is the crucial point. Is this equation equivalent to this equation? The answer is no. Okay? And the point is that when I wanted to solve this, my goal is not to solve this. My goal was to solve this. Yes? Be careful. This equation is not equivalent to that. Why is that? Can I go from here to there? I have to divide by this. Do you remember how did I come from here to here? I multiplied by this. Yes? So it means that if I want to go back, what I have to do, I have to divide by this to go back. Is that clear? But is division always possible? The answer is no. Because if I start dividing, I can always divide if what I am dividing by is not 0. Yes? So for example, if this is true, can I conclude that this is true or not? Do you agree that if this is true, this is also true? Yes. But if I want to sell this to you, do you buy it? No, because this is actually completely meaningless. So be careful. Going from this step to this step is multiplying, but going back, it means that I have to divide. I am only allowed to divide if I know what I am dividing by is not 0. But it is not guaranteed yet, because what I am supposed to be dividing by, I am supposed to divide by this expression. Is it guaranteed that this expression is not 0?
No.
No, because there is a variable inside. We don't know what the variable is yet. So how can I be sure that this is not 0? It might happen sometimes that you get an answer. For example, if I've gotten x equals to 3, 3 was a false root, because if I put 3 here, this expression becomes 0.
Yes.
So be careful. I want you to understand, of course I can teach you in this way, find the answers and go back to the denominators. If it doesn't make these denominators equal to 0, they are acceptable, otherwise they are false roots. Yes? But then this is not understanding. Understanding is that I want you to understand where the source of this false root is. Yes? The source of the false root is because going from this to this is not reversible in general. Unless someone guarantees you that this is not 0. Yes? Here, if I want to go from here to here, I can immediately go back, even if I don't know what value of x is. I don't care. For every value, this operation is reversible. Yes? But this operation is only reversible if none of these expressions are equal to 0. And it is not guaranteed yet. So without knowing the answer, I am multiplying this. Implicitly, I am assuming that they are not 0. So it might happen that this is indeed not the case. So be careful. If I want to summarize it now, so if I give you a rational equation and I ask you to solve, you can use this method and then you will find some roots according to the knowledge that you have gained so far. But before admitting them, accepting them, you have to be careful and check it against the original equation before multiplication process. Yes? So x equals to minus 5. Does x equals to minus 5 make trouble for this? No, because minus 5 minus 1 is minus 6 and it's acceptable as a denominator. Does that make trouble for this? No. So it is acceptable. Now that I am guaranteed that it's acceptable, I can say that x equals to minus 5 is an answer. What do you think about 9? Do you think it's a false root or it's a real root?
False.
Why?
Because we tested it.
No, it's not a false root. Because if I put 9 here, 9 minus 1 is 9 minus 1 is 8, and 9 minus 3 is 6. And the denominator is not 0, and the denominator is not 0. So both of them are acceptable. Yes? So here both of them are acceptable. So that is the only point that you have to be careful. We had some scenario like this before. Do you remember? It was the root equations, yes? Sometimes we solve and then you get a false root, so you have to be careful. But that's also the case here. But in the root equations, you have to be careful about that under the square root sign there should be a positive number. Sometimes it is not, and then you throw it away. But here, the only thing that you have to be careful is that these numbers that you get as an answer shouldn't make any one of these denominators equal to 0. If that's the case, you accept them. Otherwise, you throw them away. But this is the whole point. I want you to understand, because it seems that I am doing everything logically and through legal mathematics, but why I get a false root, I want you to understand what is the source of that false root sometimes, yes? And then the answer, the short answer is that this operation is not reversible. So it means that these two equations are not equivalent. Yes? Is that clear? Okay. Now, the only thing we have to do is to practice more. There's no lesson here, yes?
I have just a question.
Yes, please.
Take the lowest common multiplier for just those two,
Yes?
and then multiply them by course.
Yeah, you can do that, of course. But why we should do that? Because for harder questions, this is the most efficient one. By the way, this is not the only one. What you can do, you can tell me that, okay, let me take the common denominator as if I want to simplify this, and then using this rule, which is also very important to know, if A over B is equal to C over D, then this means A times D is equal to B times C. If you write this, that's 100% correct, okay? But I would say that this is probably the best way, because immediately, even if I want to write it, I will not write this long step, yes? But of course, in the exam, you have to show me that what you are doing. But if you want to do it yourself quickly, you really don't need to write this step. You can just do it mentally and get rid of all fractions, yes? But in that case, you simplify this fraction, because the other problem is that might be on the right-hand side. Instead of having just one number, you have another expression like this. Then you have to do this here, there, and then use that rule. But of course, that's true. Yes. Okay, let us try to do some more exercises. Okay, so I will solve one more, and then I will give you some to think about, and then we see how it goes. Okay, so number 2. So 2x minus 1 divided by 3 plus 3 over x minus 8 equals to x minus 5 divided by x minus 8 and then plus 3. So you want to solve this rational equation. So let me just repeat why it's called a rational equation. I have asked you to solve the following equation. So it means that I have an equality somewhere. I have an unknown variable x in this case, and I want to find the appropriate value for x so that when I replace x with that value, the left-hand side becomes equal to the right. Okay, so what should I do again? So can you tell me what is the least common multiple in this case?
All
Yes?
3 times x minus 8
8.
squared.
No. You don't listen to
3
me.
minus x without the
Dumbass.
other one because they're the same. So
Yes.
3 times
3x
x minus 8.
Of course, 3 times x minus 8 to power 2 will work, but that's just the common multiple. It's not the least common multiple. I really want you to learn to multiply it by the least common multiple. So the least common multiple, of course, the denominator here is 1, so you don't need to be worried about. So the least common multiple is 3 and x minus 8. So I would write 3x minus 8. Okay, and then I will write 2x minus 1 over 3 plus 3 over x minus 8, and then equals to 3x minus 8 multiplied by x minus 5 over x minus 8, and then plus 3. Yes? And then let us do this step in our heads. When I multiply this by that, the whole point of this method, if this is going to be more efficient, is not to multiply, is to simplify and then multiply, yes? So when I want to multiply this here, what will happen, this 3 which is in the denominator will cancel that 3. What is left for me is just x minus 8, and this is supposed to be multiplied in the numerator, yes? So this becomes x minus 8, and then multiplied by 2x minus 1. And then I have addition here, so I will write that, and I repeat the process. But this time, when I want to multiply this here, this x minus 8 and this x minus 8 are cancelled. What is left for me is 3, and 3 should be multiplied here, which will give me 9. And then I repeat the process there. So what happens? This one with that one are cancelled. 3 is left. I have to multiply it by x minus 5. And then when I multiply it here, nothing is cancelled. 3 will be multiplied by that 3, it will give me 9, and of course x minus 8 is also left, so I will write this. So the whole point of this method is that you face an equation without denominators instantly, yes? And hopefully solving an equation without denominators is easier for us to do. But if I ask you here, let me just test your understanding, is this equation equivalent to this equation? No. Because this step is not reversible. Unless someone guarantees that this is not 0, we don't have that guarantee yet because we don't know x. Might be we are so unlucky that the x is exactly 8. In that case, that's not possible. Yes? Be careful about that. And then the rest of it is actually a Math 2C problem. You just multiply that. So this becomes 2x squared minus x minus 16x positive 8, and then I have a 9 here, and then I will multiply this in, so 3x minus 15, and then plus 9x minus 72, and then you start simplifying. So I have 2x squared here minus 17x plus 17, 8 plus 9 is 17. On the right hand side, 3x plus 9x is 12x, and then I have minus 87, yes? Okay, it is clearly a quadratic equation, so it is better to move everything to the left. 2x squared is alone. I have minus 17x here. 12x will go and join it. It becomes negative 12x minus 29x. And then 87 plus 17, yes? So what happens? It becomes 104, yes? Yeah, the numbers are a little bit bad, but let us just face it. Okay, anyway, I have to solve this equation. Of course, you can use the calculator here, but let us see. I might need your help for the calculator.
It doesn't have any solution.
Doesn't have any solutions?
No.
Okay. Hopefully I haven't done any mistakes. Did I? So let me double check. 3x minus 8, so that is correct. That one is also correct. That one is also correct. And then that one is also correct. So 2x squared minus x minus 16 plus 8 plus 9. 3x minus 15, yes. And then minus 17 plus 17. And then I have 12x minus 87, yes. And then when I move everything to the left, it becomes that. Okay? So if I want to solve that, delta is negative, as you say, if that's correct. So delta is b squared minus 4ac. And what happens? It becomes 29 squared minus 29 squared minus 4 times 2 times 104, yes? What is this number?
800. 841.
841. And then this one?
840.
So
The
that,
answer is 9.
yes, there is a number. So yes, it was not a waste of energy, yes? So this becomes 9. And that's positive. So it means that x is negative b, which is 29, plus or minus the square root of delta, which is 3, and then divided by 2 times a, which is 4. Yes? Agree?
Yeah.
Okay, and then there are 2 solutions. So one of them is 29 plus 3 divided by 2 is 8. And then, or the other one is 29 minus 3, 26, divided by 4 is 13 over 2. And then you see that one of them is not acceptable. Because x equals to 8 makes the denominator here equals to 0. So this is a false root. It's very important to remember. It's a false root. So this is the only solution. So this can happen. You see, when I am multiplying this by that, implicitly I am assuming this is not 0. But which was not the case, because one possibility is that x is equal to 8. So x equals to 8 is a solution to this equation. But this equation is not equivalent to that equation. But one thing is important to understand. The point is that whenever this is true, so this means that if this is going to be true, then this is going to be true. So it means that the solutions that I get are more than the solutions that I get. So the solutions here should be among the solutions here. Yes? So you don't need to be worried about that I am missing something. Because I am telling you that this equation is not equivalent to that equation. And I am solving this equation for you. Yes? Instead of the original equation. But you don't need to be worried about missing something. Yes? Because the number of equations, the solutions that you get here will contain all the solutions here, but it might contain more, not less. Yes, but that's important. So you see that this sometimes happens. When you solve the equation, you get a root, which is not a root to the original equation. You have to show me that you respect by writing the false root and then accepting the other. Yes? Is that clear? Okay, so let me write one for you to see how you can solve the problem yourself. So this first part is actually important to find the LCM. Okay, so let me write number 3 for you. Yeah, let me write this one. It's a little bit simple, but you can do it. So 8x minus 3 divided by x plus 3. And then you have minus 2x. And then you have 4 minus 3x squared divided by x plus 3. Okay, I want to pause this recording for the time being, and I wait for you to solve the problem, okay? It's easy. Okay, I will write a few more here, so if you're done, don't waste your time, okay? Okay, did you solve the first one at least? So what's the answer?
5.
Yeah, because I solved it using GeoGebra, yes, the answer is 5.
Yeah.
Pardon?
I got it right.
Okay, good. What about the second equation? What is your answer?
2/6.
1/3.
2/6 is correct. 1/3.
Damn.
According to GeoGebra. I haven't solved it myself, but I typed these equations in GeoGebra and I see in front of me that the answer to the second equation is 1/3. What about the third one?
I didn't do it.
Okay. But at least the third one is a little bit hard one. We had some idea before, of course. I want to use that idea. Okay, let us start solving them so that if we have more time we can practice more. So, if I want to solve that one, so what I have to do, because you got the answer right, so let me do it a little bit more quickly here. So here, number 3. So what is the LCM here? X plus 3, yes? So I have to multiply everything by x plus 3. So I will write x plus 3 here. And I multiply 8x minus 3 divided by x plus 3. And then I have minus 2x. And then I will multiply x plus 3 on the right hand side as well. So let us just do it. If I multiply this here, x plus 3 and this x plus 3 will be cancelled, so nothing is left for me to multiply, just 1 is left. I multiply 1 there, it becomes 1 this. And then here, when I multiply it here, there is nothing below this to simplify it with that one, so I have to multiply everything there. But I prefer to write this one first and then this one second. And on the right hand side, the same story. So this will be multiplied here. But I have a negative sign, I multiply this here, this will cancel that one, so what is left for me is 1 times 3x squared, which is this one. And then I can simply solve the problem. So it becomes 8x minus 3, I multiply this in, so minus 2x squared minus 6x. And then here I will have 4x plus 12, and then I have minus 3x squared, yes? So we can do a lot of things in our head, yes? Minus 3x squared, I move it to the right, it becomes positive 3x squared minus 2x squared here, it becomes x squared. And I have 8x here, minus 6x, which is 2x, but I move 4x to the left, it becomes negative 4x, and that 2x, it becomes negative 2x. And then I have minus 3 here and 12 there, I move 12 to the left, it becomes minus 50. Yes? Yes? By the way, I don't know how many of you solved this equation using the ABC formula or PQ formula, but now that you learned how to factorize this, you can do it quicker. Okay? So let me, instead of doing this, of course you can just exactly follow the PQ or ABC formula, that's 100% right, but I would say that let us factorize, if possible, the left-hand side, if possible. So it means that I put an x here and an x there, and I ask myself, I need two numbers whose sum is minus 2 and the product is minus 15. Could you guess those numbers? Minus 5 and positive 3. So I would put minus 5 and positive 3 equals to 0. And this is not compulsory. You can just solve it normally using ABC or PQ formula. But this is also an alternative, that now that you know how to factorize it, it might be a little bit quicker. And then what are the answers? By the zero product rule, the product of two numbers is equal to 0. So either the first one is 0, so which gives me x is equal to 5, or x is equal to negative 3. But before accepting both of them, be careful. Is negative 3 acceptable?
No.
No. So that's a false root, yes? And this is the only answer acceptable. If you really want to test that this answer is acceptable, what you are supposed to do, you go to your original equation, wherever you see x, replace it with 5, and then calculate the left-hand side and the right-hand side, they will match. Yes, that's the way that you can test if you've done it correctly. Is that
But
clear?
Baba,
Yes?
aren't you supposed to do that at the beginning? Like look at the interval where the denominator couldn't be 0.
This is not a have to. You can say that, okay, the domain of this function
Yeah.
is x shouldn't be equal to -3, and then you will solve that one. The reason that I didn't like it, because, for example, for this one, here it is trivial,
There.
but here you have to solve the equations to see taking these things out. Yes, for no reason. But I want to do it faster and more efficient, so that is better. But if you do it in that way, that's also good. Okay, so we are done with this one, and hopefully everyone actually understood what's going on. Let us go to the next one. One of you answered this one a little bit wrong, yes, Robert? You said.
I fixed it.
Okay, you fixed it. That 1/3 is correct, yes? So GeoGebra doesn't have any problems, yes? And by the way, GeoGebra also knows about don't take the false root, yes? Because GeoGebra only answered x equals to 5, yes? Okay, so let me try to solve number 4. For number 5, I want you to discover to be a little bit creative. If you don't want to be creative in number 5, you can solve it, but the algebra becomes messy. But if you think wiser, you can have a little bit of shortcut. A little bit, okay? We had it before. I think I talked about this before. If I mention the name, might be you will remember, but I don't want to mention the name now, okay? So, what was the equation? Can you read it for me? I accidentally cleaned that. So, what it is x minus what?
X plus 2
X plus-
divided by x
sorry.
minus 1.
Okay, x plus 2, x minus 1, and then
X minus 4.
4. That's good.
2.
so here, so this is, we have to be careful. If I ask you what is LCM in this case, what's that?
2x times, well, okay, it's the third.
It's the third one. So be careful. Here, if you want to find the LCM here, this is already in factorized form. This is already in factorized form, but you have to be careful that I have to factorize this before doing that. So this I pull 2x out. What is left is x minus 1.
Yeah.
And then between these three, I need to find the LCM. So as you mentioned, it is this one. But you need to write it in the factorized form. So what I do, I multiply everything by that expression, because that expression is enough. It serves for itself and these two, yes? So this becomes x minus 1. I multiplied by x plus 2, you said, yes? X minus 1. And then here plus x minus 4. And then 2x. And then on the right hand side I will have 2x, x minus 1. Yes, I myself prefer to write this denominator in the factorized form, yes? So we multiply this. But then if I multiply this here, this will cancel that one. 2x is left for me. 2x will be multiplied there. And then I have addition. I multiply this by that. 2x and 2x are gone. X minus 1 is left, which is multiplied here. On the right hand side, everything is actually simplified. 1 is left. 1 should be multiplied by 4, which is 4. Understandable?
Yes.
Okay, and then I multiply. So this becomes 2x squared plus 4x. And then I multiply these two as well. So it becomes x squared minus, you can do it in your head, yes? Minus 4x minus 1x. They are supposed to be added at the end. We can add them right now, yes? It's minus 5x. And minus 1 times minus 4 is positive 4 is equal to 4. And then I want to simplify this. X squared and 2x squared is 3x squared. 4x minus 5x is just simply minus x. And then if I move this 4 to the left, what will happen? It becomes 0. Of course, you can use PQ formula for that, or ABC formula, but I would prefer to factorize it again. It's easier, yes? I factor an x out. So let me go horizontally here. There's no space. I take x here. It becomes 3x minus 1 equals to 0. It gives me two alternatives. Either this one is 0, or what? this one is 0. But this one is 0 in your head, you move 1 and then divide by 3. So it becomes a third, yes?
Yeah.
So I don't understand, Gustav, how did you got 2/6/6? You didn't simplify. Yes.
No, I didn't simplify.
So be careful. This is so if you see it works. This problem was not hard, and if you don't simplify, you manage to solve it correctly.
I used ABC, and then I didn't simplify.
Okay. Okay, but which one of them is not acceptable?
0.
0, because I will have problems here. So that's a false root. This is acceptable. Okay, I don't know. Do you remember what was the name of the trick that we want to use for this problem? Because first of all, let me test your understanding. Could you, in principle, the first thing that comes to mind is to do what? To find the LCM. And for finding LCM, the first thing that you have to do in principle is factorizing, yes? But do you think this quadratic polynomial can be factorized? How are you sure about that?
Because the delta is 0.
The delta is negative.
Negative.
Yes. The delta is negative. If you calculate the delta, there are no roots, so don't spend energy on that to find those numbers. Delta is negative, delta is negative, delta is negative. So it means that forget about factorizing them. So if I want to solve the problem right now, I don't have any hope for factorizing. So can you tell me in this form, what would be LCM? The product of all of them.
Yeah.
Yes, and then it would be big, yes? Because if I want to take that one and multiply it here, one of them will be cancelled, two of them will be left, and I have to multiply two of them. It gives me 9 terms. The other one gives me 9 terms, the other one gives me 9 terms, yes? It's not that big, it's 27 terms, we can manage it. But we can have a better way if you are a little bit smarter here. Yes?
No, the first one is x power with 2 minus 2x plus 3 minus 1.
Yes?
And the third one is x power 2 minus 2x.
Oh, you pushed it too far. Yeah, that's correct. So, yes. So, and then you want to introduce a new variable, yes? And you remember it was called auxiliary variable.
Yeah.
Yes? We had this. If something repeats itself a little bit in the equation, so I will take this one and give it a new name. It doesn't mean that I am doing something simpler, but instead of writing so many things, I just write a little bit less. What actually Benjamin said is actually probably is the most efficient way, but I didn't want to follow that. So which one do you think repeats itself here? I will also talk about what the first Benjamin said. So you can say that, okay, x squared minus 2x is repeating itself. This is the first thing comes to mind. Or you can say that I can take this one, and then I will write this is this one plus 1, and this is this one plus 2.
Is that easier?
Yeah, it is easier.
Yeah.
But the one Benjamin said is probably the easiest one because of symmetry. He said that let us take this one to be your variable, and this one is minus 1 of that, this one is plus 1 of that. I would rather to do this, okay? But everything that you want to, even if you take this part, this will work. So what I'm telling you, I would solve this problem and let us follow that method, okay? So I would say that this you need to write. I don't know which name you want to give it, so let us call it
Y.
y. Let y be equal to x squared minus 2x plus 3. This is called the auxiliary variable. Okay, so I am introducing a new variable into the game. The point is that using that I want to make the equation looks simpler. Okay, so do you think this will work? The answer is yes. But the point is something. When you introduce an auxiliary variable, you are not allowed to have a mixture of the old variable and the new variable. Okay, so you should be able to write everything in the equation in terms of your new introduced variable. If you want to have a y and in the same time x in the problem, you are making the problem harder, not simpler. The problem was one unknown, you are making it into one unknowns. Okay. So what we are doing, I would say that let this, and then what can I write for x squared minus 2x plus 2? This becomes y minus 1. Everyone agrees? If I give this the name y, then this one becomes y minus 1, and x squared minus 2x plus 4 becomes y plus 1. Okay, and then I will replace everything according to this new variable. So this equation would be 1 divided by, instead of x squared minus 2x plus 2, what can I write? I can write y minus 1, and then I will write plus 2. X squared minus 2x plus 3 is just y, and on the right hand side it becomes 6 over y plus 1. Agree? So this equation is nothing except that equation, but instead of working with x, momentarily I am working with a new variable which I call the auxiliary variable. Yes? And I will solve this problem. I hope that you agree with me. This is probably a very simple equation for you now. So what would be LCM in this case?
Product of all.
Yes, product of all. That's coincidence here. So I would say y minus y, 1, and y plus 1. I multiply it on the left, and I will also multiply it on the right.
Well, couldn't you use the conjugate rule?
Here,
Y minus 1, y plus 1.
no, not now, because I want to have it to simplify it.
Yeah.
Yes? And of course, that's a conjugate pattern, but you need to know where to use it so that it makes it efficient. Okay, so what I do, let me clean this part now. Okay, so we go and multiply this in, but in your head, this one and that one are gone. Y and y plus 1 and 1 are left. I multiply them, so it becomes y plus 1. And then I will do the same thing here. This time, y will simplify that y. 2 and y minus 1 and y plus 1 are left. On the right hand side, y plus 1 and y plus 1 are cancelled. So I have 6, y and y minus 1 are left. Now I multiply in, so it becomes y squared plus y. But here, as Hussein said, I will use conjugate pattern here, because my point is to multiply them. So it becomes 2y squared minus 1. And then on the right hand side, I will have 6y squared minus 6y. And then here, 2y squared plus y squared is 3y squared. I have y here. I have minus 2. And then I have 6y squared minus 6y. Okay, so I have to simplify everything. So I move this to the left. It becomes negative 6y squared. With this one becomes negative 3y squared. This becomes positive y and another y here, positive 6y, another y here, 7y minus 2 is equal to 0. Yes?
Yes.
And what I'm supposed to do now, I have to solve this equation. Let me use delta, for example, formula. So delta is this number to power 2 minus 4 times this, which is positive 12. Positive 12 negative it becomes negative 24, and the answer becomes 25. And then what I have to do, I have to write y equals to, not x, because I am solving an equation in y. So it becomes minus b plus or minus a square root of delta, which is 5, divided by 2 times this number, which is minus 6. Okay, so let me write it here. So then this means that y equals to minus 7 minus 5 is minus 12 divided by minus 6 is positive 2, or minus 7 plus 5 is negative 2. Negative 2 divided by negative 6 is a third. Yes? Okay, you can actually see that. Is there any false root here? because we are solving this equation. The only problems in this equation are 1, -1 and 0. Yes? But we got 2 and a third. Am I right or not? Yes? Okay, now this is not finished because my goal was not to find y. Y was not in the problem in the beginning. I introduced it myself to make the problem simpler, but at the end I have to go back and solve for x. Okay, so I would say that y is equal to 2. This implies that x squared minus 2x plus 3 is equal to 2. And then I have to solve this equation. This is another quadratic equation, so I have to move it to the left. So this becomes x squared minus 2x plus 1 equals to 0. Of course I can use ABC or PQ formula, but there's a simpler way to do that, yes? This is a familiar pattern, hopefully. Yes. It's x minus 1 squared is equal to 0. And then what does this give me? This gives me x equals to 1. Is 1 acceptable? Yes. Because if I put 1 here, I will not have any problems here. So 1 is the answer.
Wait, how did you choose between 1/3 of y and y equals to 2?
Not yet. This is one of them, and then I have to do the other one. Yes. Yes. 1 over 3, and then this means that I have x squared minus 2x plus 3 is equal to 1 over 3. Yes? Again, I want to get rid of fractions, so I multiply everything by 3. So this becomes 3x squared minus 6x. If I multiply this by 3, it becomes 9. If I multiply this by 3, it becomes 1. If I move it to the left, it becomes 8. And I have to solve this one as well. But according to GeoGebra, this is the only answer. So let us check. If I calculate the delta here, it becomes this number to power 2, which is 36. Minus 4 times this, which is 12 times that one is 96, which is negative.
Yeah.
So there are no solutions coming in, but you have to check it. If you don't check it, it's not correct. So it means that no solutions. And then this is the only solution. So the answer to this problem is x equals to 1. Yes, is that understandable? Okay. So I spent a little bit more time than usual on these rational expressions because they are important. So there's one topic left in this chapter, and that is a very important topic of limits. I don't know why they have mentioned it in this chapter. We can also do it in the next chapter. Let us see how it goes. Okay? Thank you very much.
Thank you.